Hi, everyone. I'm Zhou from LTI and CMU. So today I'm basically going to talk about my thesis work on situated intelligent interactive systems. So let's first start. Most of the great research was inspired by something creative. So around 2013, there is a movie called Her. I don't know how many of you guys have watched it. So we have pretty good numbers in this. So it's a movie about a personal assistant that Scarlett Johansson voiced that is able to work with the user, even later started a relationship with him. So if we take some snippets to illustrate this kind of a perfect vision for personal assistants.
Morning, Theodore.
Morning.
You have a meeting in 5 minutes. You want to try getting out of bed?
You're too funny.
Okay, good. I'm funny.
So you can see the personal assistant here can really aware situation of the user. She knows that he's having problems getting up, so she's using a kind of a funny way. The prosody really helps in getting him out of bed. And then if we
I saw in your emails that you'd gone through a breakup.
Well, you're kind of nosy.
So what was it like being married?
There's something that feels so good about sharing your life with somebody.
So we see that one more step further, the personal assistant is trying to understand the interpersonal relationship between the user and his friend and his circle. So we see that the assistant then later can really insert herself into the group of people that the user is situated.
I want to learn everything about everything.
I love the way you look at the world.
So finally, he's trying to learn the social and culture, the big environment around the user to be able to situate in this society. So we say that this kind of in computational ways, you see this kind of a clear 3 steps of the system trying to learn to be really good ones. But let's see the reality here. So it's a video I recorded 2 days ago, so no cheating about the advanced system.
Can you recommend me some restaurants in the Seattle area?
The best rated option I found is the Cheesecake Factory.
I'm not approve of that.
How expensive is that restaurant?
Does that one sound good?
You didn't answer my
You
question.
didn't really.
If you say so.
We can see that she didn't really answer my question, and I confronted her about it, and she's just being very passive. She's not trying to resolve this kind of miscommunication here. So my work basically is trying to see how can we bridge this gap from this personal assistant from the science fiction to the harsh reality we are about the personal assistant we have, like Siri and his brothers and sisters. So we say that first, the paramount thing about a system is to be aware of the situation it is situated. Situation can be a lot of things, like people, for example, the users, time, for example, the history, environment, for example, the physical environment. So here, like user engagement, how engaged he is in the conversation is one type of situation that the system should be able to aware. And then after we are able to be aware of the situation that we care about, we can take interventions. So what we hear is saying actions that to react to these situations. For example, we can use certain active participation strategy to improve users' engagement if we detect that the user doesn't have the engagement. Finally, we bring everything together saying that because conversation is always a sequential decision, if you think of it a way, you can formalize into a reinforcement learning problem. So here we really wanted to say that we want to take the situation, whether it's the user, whether it's the history, into consideration to choose among the actions that we designed to optimize towards a long-term interaction for effectiveness and naturalness. So this is the framework that I proposed in my thesis. So here is an example that we did for a system that social chat with people. And here we care about the situation engagement, which is users engagement, whether she wants to stay in the conversation or not.
How are you doing?
I'm fine. How are you? Any thoughts?
Any thoughts?
At this point, we detect that the user is not engaged by multimodal informations, such as look away.
Let me see. Do you
We
want
provide
to go to my
a strategy
friend's
to bring it
party
back.
tonight?
No, I have a lot of work. I can't go.
Every day.
As we all know, CMU graduate students have a lot of work to do all the time. So we say that these kind of situation-aware systems are not limited to personal assistant. It has a wide applications to different things. For example, in education, can provide trainings, language trainings to users. You can facilitate discussions in online educations. In healthcare, you can support therapies, provide therapies for depression, aphasia, and dementia. For entertainment, you can definitely have more targeted advertisement for the individual users. It is also applicable in different platforms. We are not saying that these kind of systems, dialogue systems are only virtual. You can also have physical embodiments. For example, robots. You can have the robots to give directions with gestures. You can have the robots do the nursing and rescuing tasks. So let's step back a little bit to see where my work really situated in the history of spoken dialogue system. Around 1990, we had a prototype of it from AT&T, which can sort of function. And 1999, we had a real academic demo around that time, MIT Jupyter. Later, we have CMU Let's Go system. And 2009, we had a Cambridge restaurant, which is their agenda-based system. And now, around 2010, we had a really good boost in terms of automatic speech recognition. We have better speech recognizers, so we can do real applications in the wild. So later, we had Apple Siri. Google now follows Microsoft Cortana, all the sisters and brothers. And Amazon Echo, which is an embedded device. Google Home, which is a smart device, smart home device. So my work is around, we started in 2014, we proposed my thesis topics, saying that the systems need situation intelligence, and that is paramount to have your system work well with the user. We recently won a Alexa Prize challenge that is going to integrate my system in Amazon Echo. So if we see this kind of a trend, it's around 10 years we have one step from the primitive prototype to academic demo and then industrial products. So my work is around 2014. I hope in 5 years or 7 years later, it can be really integrated in the systems we use every day. So here is just an outline of what I'm going to talk about later. We bring two instantiations of the situation intelligence framework. One is to care about the engagement of the user, and the other is attention. And within the engagement coordination framework, we're going to talk two types of systems that people usually differentiate in dialogue systems. One is non-goal directed, and the other is goal directed. So we're going to first start with a social conversation. So here we say engagement. Why do we care about engagement? It is one type of individual awareness. We define it as the interest to continue to contribute to the conversation. So it is universal for all conversations. We all need this kind of a continuation to be able to open the channel for communication. So social conversation, in another way, is very interesting. It serves a certain kind of a cohesion for really complex tasks. So whenever you walk to your coffee corner, you talk to your coworkers. You don't ask him, have you finished your task first? You ask them, where's your weekend? Then you slowly, gradually go over to work parts. And you would adjust to it because, for example, he had a really bad day. You probably shouldn't ask him a favor at work. So we say that this kind of social conversation can be a smoother computer tie between your conversational partner. Can also elicit information to better tune your later moves. The other major reason is social conversation is relatively independent of strong domain knowledge. Not like education, you have certain steps to go through in order to teach somebody for things. So we can really focusing on the conversational theories that we care about to make sure that the conversation is ongoing. So when we talk about social conversations, we had all experienced it. Most of the people have experienced talking to a chatbot. So here are some complaints that I collected. They're really bad at being interesting, bad at understanding, bad at remembering things, bad at being coherent, bad at providing variety, bad at being natural and didn't do anything. So we all hear them sometimes. If you categorize them up, you see that basically some people find there's no motivation talking to a chatbot. Chatbot is really bad at open domain language understanding. It sort of don't have very personalized experience, never remember anything about me. And then a lack of topic coherence, it jumps everywhere. So my work is basically trying to see if we can solve these kind of complaints in a certain degree using the situationist framework. So back to the 3 steps that we introduced in the situation framework. We had engagement. So here we define engagement just so remember, as they're defined it as the interest to continue the conversation. So we first started a study to see how can we automatically recognize engagement in real time. So according to literatures, engagement is a phenomenon really hard to identify. However, there are some cues we can leverage in figuring out engagement. So of course, verbally, there are word counts, turn lengths, the time the user takes to respond to a system. Visual-wise, we have head pose, or looking at me or not. Action units basically can further infer your smiles and frowns. Gaze directions. Then not only what you say is important, how you say is also important. There's a lot of information encoded in prosody as well. So basically, we're going to bring all these kind of multimodal informations together to predict users' engagement. We conducted a study by collecting 23 interactions and labeled it. And we do find that after inter-annotator agreement, we see that Peekapole can sort of annotate engagement reliably if it's a 2-point scale, engaged and disengaged. So we trained our machine learning model to automatically detect them. So one thing, remember that we don't have a lot of data. It's always the case in the multimodal interaction community. So we just used a simple SVM method. So neural network model doesn't really apply here. So we do find that we can do pretty good in terms of F1 measure. We got 0.8. And we do find that adding different modalities really work together. So the feature selection here just means we have a step regression model to choose in all the features we have, so that we make sure that we include all the features that are complementary to each other. We do find that our combined model is better than individual models. So at this point, we say that we are able to detect user engagement in a pretty reliable way. So the next part is, if users are disengaged, what should we do? We designed sets of strategies to help regulate that. So here, first of all, one is called active participation for engagement coordination. So basically, we want the system to take an active stand to engage the user, to bring him back to the conversation. So we have 2 categories majorly. So for example, a simple way is like tell a joke. Initiate activities. For example, do you want to see a movie together? Talk more, ask the user to talk more about the topic, or switch the topic, or asking an open question, or refer back to engaged topics. So for example, you say, you like movies, do you want to talk more about that? So we take these kind of 6 strategies and tested them with real users. So here, we collected around 30 multimodal conversations, and we say that we wanted to test on the policy simply. Basically, if we find that user is disengaged, we would randomly select one of the strategies here. So we say that we're doing pretty good in some of them, but not all of them. So for example, here, the open and switch was not doing that good. and in initiation is a little bit better, but joke was not that. The refer back is always really good. So later I'm going to talk about why they're not good. So basically a hint is that if you just do random selection, you don't consider the context. You don't really get this kind of a coherence, which really affects engagement. Another type of strategy is called a grounding strategy, which is for assisting language understanding. So we utilized a general knowledge base, such as Google Knowledge Graph and Wikipedia. So we designed strategies such as ground out named entity to help user. So grounding here really means trying to bring the user on the same page to be sure that they have a mutual understanding what they're referring to. So for example, named entity is like, for example, like Clinton. At this point, the system doesn't really know which Clinton he is talking about. So he's trying to collaboratively dissolve this kind of this ambiguous by asking, are you talking about Hillary or Bill? The second one is called ground out of vocabulary words. So basically, if we find there is words such as confrontational we don't have, and then TikTok could ask him, what is that? The other one is called single word. Especially in typing scenarios, users could just do like one point, just use these all kinds of really interesting small tests for the robot. Basically, we're trying to make sure that we can basically be confronted about him. Why are you asking me this? So we implemented in basically using previously designed algorithms, for example, Stanford parser to detect named entity, and then refer that back to their knowledge base and get the most frequent answer and try to generate it through statistical templates. For this one, basically we query the knowledge base to find the outer vocabulary words and use a template to generate it. We always update the knowledge base for sure as well to make sure that we understand. For this, we do the same thing to find if the single word is not in the knowledge base, then we basically confront it. So the third type of strategy is called a personalized strategy. Basically, they are used for user adaptation. So basically, when the conversation is going on, we extracted all these important predefined relationships, for example, users' preferences, and stored that in their personal database. So each user had their own database, so that we can remember his preferences. For example, we would always remember what the user said before. We can confront him if he is repeating the same thing. So we get a lot of this kind of repeating because a lot of users just want to test the robot, what the robot is going to say if they repeat the same thing. And the other is like personal suggestions. For example, we already know that the user likes superhero movies. And basically, the next time he talks about movie suggestions, we would make a more targeted movie suggestion. So so basically we tested all the 5 strategies that we proposed in a typing scenario. So we get more data that way. We have one metric that we used for evaluating how good it is, which is appropriateness. So it defines as the local coherence of system utterance. Basically, if we use some of the strategies, we want to see if the user finds it's coherent with respect to their own utterance. We do find that most of the strategies are doing really good, but some of them have problems. For example, ground out named entities, we do find that we sometimes have errors in detecting the named entity. So basically, we had some errors. So later, we can improve them by having a more targeted named entity detector. So ground out OOVs, basically, we didn't really handle the typos. So we would confront people about typos, and people find that it's kind of annoying. So after we say that we can detect engagement reliably, we have the conversational strategy that you can select to boost the engagement of the user. Then we say that we can bring all of them together to make sure that we take context and think into consideration so that we have long-term coherence. So here is one of the strategy failures that we mentioned earlier in the random selection strategy policy. So TikTok say, hello, I really like politics. Let's talk about politics. And you say, no, I don't like politics. TikTok says, why is that? I just don't like politics. So at this point, we detect that the user is disengaged. And TikTok randomly selects one thing. How about we watch a debate together someday? And user just says, I told you I don't want to talk about politics. So the strategy didn't really help at all. If we look into the context, it's sort of not appropriate because the user already expressed it pretty clearly. He doesn't want to talk about it. If we, at this point, select a different one, saying, okay, how about we talk about movies? The user really got back from this, saying, sure, I do watch movies a lot. So it is more appropriate. So the take-home message is basically, we need to consider conversational history and action planning. So only having the actions are not enough. You need to know when to use it, considering the history. So that's why we had a policy that is having the goal saying that we want to optimize towards long-term effectiveness and naturalness. And considering situation, a big part of the situation is the history, not only the user situation. So we used our reinforcement learning method, the specific key learning, a tabular key learning. The important part is how do we parameterize the state and action in a reward space. So here we use for user's engagement confidence, basically how engaged the user is. It depends on which strategy you select. System appropriateness, how appropriate your utterance is also important. All previous utterance sentiment confidence, basically what the user expressed is also very important. Time of each strategy executed, you sort of wanted to balance them. In turn position, for example, certain strategies would not occur in the beginning of the term, for example, switch a topic. A more recently used strategy, you sort of don't want to repeat them in very close range. And actions, as we know, very simply, are basically the conversation strategies that we designed earlier, and also the generated utterance by sequence-to-sequence model and the information retrieval methods. So basically, we wanted to know that standing in which state, what action should we take? And we need a reward function to guide us to select them, actions. So the reward function basically is a weighted combination of accumulated appropriateness, conversational depth, information gain, and overall user engagement. So these are our, we first trained predictors based on human annotations for each of them. So because in real-time testing, we can't get users' feedback in real time because it's gonna get disturb the interaction. You can't really ask user every time he replied and say how appropriate you think, how much depth you think the answer is. So basically, we pre-trained some detectors with pre-labeled data, and in real time, we will use that as the approximation of these metrics. Appropriateness, as we talked about, is the current response coherence with the user utterance. Conversational depth is defined as a maximum number of consecutive utterances on the same topic. Information gain is basically the number of unique tokens, which is automatic from the very beginning. Overall user engagement, it's the overall assessment of the user's engagement of the entire conversation. So we pre-trained these classifiers. So in the test time, we can basically use the output of these classifier as the confidence score for the reward function in selecting actions. We used another chatbot called Alice, which is a Lebanon Prize winner previously. So it was composed of a lot of 2,000 different rules to make sure that they do correctly in a more constrained domain. So we used it as the simulator of the user in the training process. Basically, the Alice is talking to my chatbot and going over for different rounds. So we have two baselines to compare our reinforcement learning. One is the random selection policy, and the other is a local greedy policy. Basically, we only look ahead 3 turns to decide which actions to use. We collected around 20 multimodal conversations per policy, so basically 60 in total. We do find that by considering the history, we do reduce the inappropriateness. Inappropriateness just means incoherence. Conversational depth, we had a lot boost as well. And in terms of information gain, we had a little boost. So here, the percentage just means that inappropriate, not appropriate, deep, conversational depth is basically, are they deep and not deep, so it's binary. We also did our overall test. Basically, the baseline system is basically the one that without the strategies and without the policies. And the engagement coordination one is basically the last one with a reinforcement learning policy and all kinds of strategies. We do find that experts basically rated in a 1 to 5 Likert scale, think their engagement coordination version is much better than the baseline. And here, the number of conversational exchange here, basically we pushed it into a mechanical Turk setting. So we asked the user saying that you can talk to it for as long as you want. So basically, we will pay you anyway. So the baseline only got like 15 of them, but their engagement coordination almost doubled it. So basically, the user liked to talk to it, even not getting paid extra, which we think is sort of an ultimate objective measure for how engaging the chatbot is. Here is a simple conversation that we had in our user study. So TikTok said, "I'm not sure, what's on your mind?" And TikTok makes a joke about politicians. And then he said, "Well, that's funny and insightful." I can't answer. Can we talk about something else? It's always hard to talk on politics. And we said, "How about movies? Have you seen any good movies?" "Of course. What do you think?" "I love superhero movies. Have you seen Deadpool?" "Are you talking about Deadpool, the animation character?" So here we use a ground named entity ground, basically the Deadpool. Say, "Yes, exactly. They made a movie of him. That sounds really interesting." So we see that how the system is trying to select different kinds of strategies overall to make sure the conversation is engaging. So basically, overall, the take-home message is that active participation strategies really deals with this, improves the user engagement, deal with being bad at being interesting, complying. And grounding strategies, basically trying to make sure that they refer to the same entities, words, are helping their open domain language understandings, basically dealing with the bad understanding me problem. And personalized strategies, basically this kind of personalized suggestions really help really adapt to different users so they have their own unique experience. So it sort of creates this kind of remembering things. We can create more strategies, definitely, to deal with different things. While the statistical policy, the reinforcement learning policy, really enables long-term optimal outcomes, basically being coherent and providing a variety of, in terms of language, which is encoded in the reward function. So after we talked about this social conversation, we wanted to say that, is it really useful in tasks that a lot of people care about? So here we make it, which are goal-directed conversations. So we say that basically we can transfer the engagement predictor fairly easy. We can use the same model that we train in the non-goal-directed system and retrain it later by after collecting more data. And strategies can definitely translate because they are all very basic conversational theories about groundings, about personalized strategies. They are always useful in different kinds of conversations. Here is one type of one goal-directed conversation that we designed, which is a movie promotion chatbot. Basically, the goal is elicit the user's opinion about movies and then promote a movie based on their preferences. So here we are trying to realize the goal of how to interleave social and task contents like human does. So we can elicit more truthful opinions and better suited our goal and to serve our goal better. The task components here, basically a lot of slots that we care about, like preferred movie type. And later we use a reinforcement learning strategy. Here, one kind of a change is we add this kind of transition between social and task conversation as one of the inside of the reward function as well. So you can think of it as a very simple model. We have a system which is a task system that we built has a lot of slots. It always goes through the slots. And the social system, basically the one that we talked about, have all these conversational strategies in helping the conversation. And we have a reward function that directs which subsystem that we would choose to generate the response. Here is an example. Basically, you say, I like watching movie too. TikTok, here we chose the task one because we have an appropriate one that is coherent. We say, do you like superhero movies or Disney movies? You say, I like superhero movies. And we also choose a task one on this. We say, my favorite superhero is Captain America. You say, I like Spider-Man. And then at this point, we don't have anything that task is related to this. Basically, we say, do you watch them with your kids, which is from a social conversation? And say, I don't have any children. And then we try to recover from it. What I meant to say was, what is that you hate? You either say, I hate the last Fantastic Four movie. And then at this point, we can use sort of a grounding strategy. I say, are you talking about that Fantastic Four, the 2005 movie? I say, yes, I am. And now we are finally back to the task because we have something that related to it. So I really like the first Avenger movie. Have you seen it before? So basically, we're trying to see that we're interleaving the task and social in a way that we make sure the user finds it coherent and engaging. We tested with 50 conversations in a typing system, and preliminary finding. So we do find that because we have this task, we collected all the stats. We have 100 people answering the slots. Basically, we find that really it is sort of, I would say, it's expected. Men in their 20s like superhero movies more. When we restricted the Turks are in the US soil. We do find that, so the baseline system basically doesn't have all the social talks. It just go over to the slots. Which type of movie do you like? Do you like Captain America? Like that. And the engagement coordination is basically have the interleaving. We do find the expert rated as more engaging. And it also elicits more utterances from the user as well. So basically, the task is around 17 utterances if you complete it. So some of their users didn't really complete it in the baseline. And then some of them really completed in the engagement coordination.
What counts as completing the task?
So we would basically suggest a movie that we want to promote. So that's the task. So if he really stays over 17, then you really complete the task. Some of them didn't really do that in the baseline. Another task we really translated our engagement coordination is called interview training. So this one is on the education domain. So it's sort of very different, but we can do the same thing with it. So the task is basically the system acts like the interviewer to interview user for a job. And the goal is basically we want to improve second language learners' language ability. Communication ability is very important for language learners. We had 50 conversations per system. There is a baseline system and the engagement coordination version that has all the strategies. And the result is basically we find the system with engagement coordination was rated as more engaging and elicited more user information, which is the most important objective function that we are optimizing towards. Basically, the more you speak, the better you're learning your language. We are deployed in China, Japan, and Brazil classroom. It's a collaboration work with ETS. So we really cares about this kind of classroom change. It is also on the way to integrate with learning applications. So here is an example. We collect everything on Mechanical Turk platform. So people can basically talk to it in real time with stream all their audios and videos from the webcams and the mics from their own laptops and do all the computations.
What would you do if you had a disagreement with a coworker? Would you prefer to settle the matter directly with your coworker, or would you report the incident to your manager?
I'd talk to the coworker so he knows what he's doing and he doesn't get in real trouble. Well, maybe if he does something really, really bad, then maybe yes, I'll report him to the manager.
And what do you think the manager would do next?
Cut his pay a little bit.
So at this point, we detect that he's not engaged by averted gaze and short
I
answer.
don't really know, actually.
Yes, I think a lot of managers would do that.
So basically, the system really go over to encourage him to really participate in these actions. So the take-home message is basically here, the engagement and coordination really generalized to different goal-directed tasks. Interleaving social and task conversations can be beneficial. So it is not only limited in this kind of movie promotion, you can put it, generalize it to other products promotions, surveys. It's a better way to elicit unbiased information. And the reinforcement learning really drives this conversational flow. It can interleave this kind of different tasks really nicely. We also publish our database and code source for our dialogue system framework called TikTok as well. It supports typings, it supports audio, it also integrated in Amazon Echo right now. You also have face-to-face. So it's compatible to different mobile phones. It's a web application, and it is also multi-threaded and can be deployed on the cloud. And it has all of these kind of supporting applications such as annotations and databases. So we really encourage everybody to also develop in this framework. So the other part I wanted to talk about is attention coordination. We're talking mostly about engagement, which is one instantiation of situation intelligence. The other one we care about is attention. So here we specifically use a direction-giving robot example. So basically it's a collaboration with Dan and Eric Horvitz. Here is an example of failure.
Sorry, say that again. Sorry, say that again.
I'm looking for my meeting.
You said Matt McGinley, right?
No, give me a minute.
Right. Sorry, that was Alberto Bacala you wanted, correct? Well, guess I'll see you later.
So we see that the system doesn't have this kind of idea about that whether the user is actually looking at the phone and trying to give me a minute instead. So he keeps going on. So he doesn't seem to aware of the user's attention can really help him in the task. So what we do is go over to the literature to see what humans do. So in conversations, Goodwin identified that human-human conversations, people's speech coordinates with listeners' gaze. For example, like here. So the dotted line means Brian is not looking at Barbara, and the solid line means Brian is looking at Barbara. We see this really coordinates with the disfluencies. So we can, in another way, saying that disfluencies are not merely cognitive error. It's also a strategy that can regulate listeners' gaze. And so these examples are numerous in Goodwin's book. So basically we say that we should let the robot do all these kind of stutters too, to see if that really helps. Basically we implemented these strategies called excuse me. We can also do to get to, so it's like constitutes as restarts. And we also do repeat as well. And the kind of wait really is another form of a pause. So we basically see that we say we have a policy to choose in between all these strategies when we detect that user is not having the attention. So here is an illustration video. So here is the participant's view.
Do you need help finding something?
Yes.
Could you tell me the room number or person you're looking for?
I think it's 4800.
To get to 4800.
I think it's 4800. Yeah.
Excuse me.
4300.
Go along that hallway.
I'm looking for
You find me.
4300 is just down that hallway and will be the first room on your left.
Okay.
By the way, would you mind swiping your badge on the reader below so I know who I've been talking with? Can I help you find something else?
No, I think that's it. Thank you. Bye-bye.
Okay.
Bye.
Bye-bye.
Very nice and disengaging as well. If we see a robot's view of the same interaction, we will see all the kind of sensing going on. So we have the user's attention. Now we dropped it. We don't have it at this point. And then we decide that we should just wait. And then later, if we don't have it anymore, we say, excuse me.
Excuse me. Excuse me.
Still not coming back. So we sort of needed to do the restarts.
Go along that hallway.
So go along the hallway constitutes a restart. Now we have the user's engagement back, so we just finish the sentence.
4300 is just down that hallway and will be the first room on your hallway.
So here are some of the segments from random people walking by, interacting with it.
To get to 2800, take the elevator down to the second floor. Turn left as you walk out of the elevator and continue on to the end of that hallway.
We really see this distraction from the phones all the time.
2800 will be on that side of the building.
But this time we succeeded. We also have this one that's
Can I
not sure about interacting.
help you find something?
Can you tell me?
And there's the wandering people.
Do you need directions? Excuse me. Do you need directions?
Yeah, we think that our disfluencies worked quite well. Very interesting one. So basically the take-home message here, we see that we have different kinds of instantiation of a situation intelligence framework that they are suitable for different tasks. You really should start with from your task and all these failures to select what kind of situation that you are wanting to focus your system to. And then we see that it also generates with a system with physical embodiments that can do all the physical gestures. So the overall summary of the talk is basically saying that multimodal information, all the gaze and all the acoustics, really helpful in action planning. And if we use all these computational methods such as natural language processing and knowledge base, we can encode the conversational theories to facilitate that interaction. And reinforcement really assists this kind of long-term optimum by considering the context. And situation intelligence framework is also applicable in various domains such as entertainment and education that we showed before. And also, it can be augmented to already existing systems such as the robot, the interview trainer. So the future work part, we wanted to basically say that we mostly talked about the individual person's awareness. How are we going to talk more, how are we going to progress into interpersonal? So we had our preliminary work on friendship detection, basically use the synchrony and dysynchrony of nonverbal behaviors to detect whether the two users are friends or strangers. And then basically we can translate that into group collaborations. So if the robot really knows the relationship between all the users, he can adjust his actions towards that. So it can be applied like tutorings and meeting settings. And for social cultural awareness, basically it is a bigger picture. We did one preliminary work on how people express engagement differently in different cultures. We had TikTok speaking Mandarin, talking to Chinese people, and speaking English, talking to American people. And we do see there are differences in expressing engagement in different cultures. So basically we want to know that all these kind of systems are really popular. They're deployed all over the world. How can we really consider the age, the race, the gender, and education level, all these really big groups into consideration and make the system more situated. So finally, we say that the other directions about this kind of dialogue actions is right now we're a lot of the times when we design systems, we have an expert to be involved in the dialogue action design and flows. How can we just use this kind of knowledge extraction and knowledge encoding to automatically extract all these structures and domain knowledge transitions and then encode them back to the conversational system is very important. So all these sequence-to-sequence learnings and reinforcement learnings with neural models with structures are really some tools that we are beginning to looking at in generalizing the system to different domains. Finally, I wanted to thank all my collaborators and my co-authors on my papers. Without them, I can't really complete all the works that we have been talking about. And finally, I would like to take questions. Thank you.